Let me collapse this down. So I want to talk about multi-scene physics. There's a couple of tutorials on the Unity site on this. One, the basic multi-scene physics, and the other, a fairly elaborate Ghost Racer game that I haven't figured out how it works yet, but replays your racing with a ghost image. So before 2.18, Unity had only one physics engine in a scene, but in 2.18 they added the ability to have separate physics engines occurring in a single scene. And as such, colliders don't collide. The time scales can be set different. So, one world can be running faster or slower. And the one application that I can think of for this is kind of the ability to predict trajectories without committing to them. So you can have this kind of alternate physics world that you can trigger and see what will happen without moving any of the stuff in your main world, and so you can then decide whether to commit to it or not. So the basic multi-scene physics walks through the building of one of these, and with this we have two scenes that we've stored in the build settings: a main scene and an alternate scene. And in the main scene, shown over here, I've got a ramp and I've got a ball with a rigid body, and the ball's going to fall and bounce and roll down the ramp. In the alternate scene, the ball is at a different position and the ramp slopes a different direction. So in this alternate scene, I have the same plane and sphere. I have no cameras or lights, and apparently that's important, that you don't want to have cameras and lights in the alternate scene. And both of these have to be in the build settings. So the main has an object with this physics scene loader script on it. And in the awake function, it's going to set some parameters for the load scene that's going to occur. And in particular, we're going to load it additively. So instead of replacing the scene, we're adding it to the scene. And we also have the second parameter there, the local physics mode, which we set to physics 3D. And there are some other options for the local physics mode. Then we actually load the scene, load this physics scene. It's done by name with these parameters that we just set. And then we catch a copy of that physics scene from the scene get physics scene. And this is actually a scene extension. It's kind of hard to find in the documentation. It's not terribly well documented, but it gets the physics of this local physics mode scene that you've established. So then these physics scenes don't simulate automatically. You actually have to simulate them yourself with a time step. And so in the fixed update, which of course is where physics gets carried out, if we have this alternative physics scene, we simulate the physics scene. This is the physics scene that we caught right here from the get physics scene. And we're doing this with the time delta time, the fixed time step. And I have a settable physics scene time scale, which I believe is just by default 1 here, but one could adjust this and have the two scenes run with different rates of time. And so if I'm in my main scene, and you can watch down here what happens when I start this. First of all, it loads the alternate scene. We have now the red plane that's at a different slope and the red sphere that's in a different position. And the two of them are going to run their physics, but they're not interacting with each other's world. The red things are bouncing through the green things, and the green things are bouncing through the red things. Interesting, the lighting all kind of works as though everything were there. So clearly the lighting is not participating in this. I kind of wanted to see here what the difference would be. So in this second one, I have the two balls in the same place, but the planes differ by, I think, 1 degree. So the green plane is at 5 degrees and the red plane is, I think, at 6. And so we can see here now the different trajectories that the two balls take as they experience their slightly different physics world. I thought this would be an interesting thing to demonstrate the butterfly effect, which is that small changes in initial conditions in chaotic systems end up in completely different results. And so I have a ball bouncing around in a box here, and the green sphere is moving 16 and 15. I believe the red sphere is moving 15 and 15. So a difference of about 3% of the velocity of my initial ball. And so that slight difference in initial conditions in this chaotic system results in two completely different outcomes. And if one were to imagine that this were some elaborate simulation of weather, and these were storm systems, in one case we have a storm over the northeast, in the other case we have a storm over the west. So that's kind of a kludgy demonstration of the butterfly effect. So with this idea of predicting trajectories, I thought I could apply this to a billiard game. And I found a simple framework from a guy named Ditzel, his 1 hour billiard game. He claims he built it in 1 hour, and it's entirely possible. But let me get that scene going here. Quit this one and open billiards. So the idea in the billiards here is that I've got, I'm going to have two sets of objects. I'm going to have two sets of all of the balls in my two worlds. I've got the main scene here that has the billiard table, and it has the white cue ball, and it has all of the normal balls, the red balls here. And I have this alternate scene that has all of the same things, except the cue ball is blue and the normal balls are, I think, green. So, you know, differences between them, but this is the exact same setup as what I showed you before there. And in the main scene, we can't see this. So I found that in order to keep our balls synchronized between the two scenes, it was important that the manager had information about both scenes' objects. And as such, I'm going to use custom tags, and then I'll be able to find game object with tag and find game objects with tag to locate the various objects. And I'm going to have custom tags for the cue ball, the normal balls, the line that I'll show you in a minute, and the ghost cue and the ghost balls for the alternate scene object. So I can locate all these objects once the world has gotten going. So this game manager is the thing that, of course, controls the aiming and firing of the real and the ghost cue balls that then go on to hit the various normal balls, both in the main and the alternate scenes. And I've got various public and private variables that keep track of all of this stuff. In Awake, I'm going to do the scene loading here, and it turned out that this was important to be in Awake because I had to be sure that the scene was fully loaded before in the start I went around and did all the stuff that I was going to do in the scene manager. So this is the same physics loader, scene loader that I showed you in those basic scenes. This is not in the game manager, and it handles the physics just like in that simple scene using a physics scene simulate. So in start, and this was the reason that we used Awake Above, now that I'm ensured that all these objects are in the world, I can go out and find the real line, the real cue, the real balls, the ghost cue, the ghost balls, and set up the real line renderer, get various rigid body components that I'm going to be accessing, all of which are stored in various arrays, and turn off the line renderer. And I've got a little UI element that keeps track of how many times I've fired my cue and also the strength of the firing. I wanted to let the balls come to rest. And so I have this test if moving to see if the balls, both real and ghost, have stopped moving. And I do this by looking for the rigid bodies is sleeping condition. So when a rigid body has stopped moving to the satisfaction of the physics engine, it then goes to sleep. And this is one of the read-onlys that you can look at on a rigid body. And so this is going to go through all of the relevant objects and decide whether they're sleeping or not, and with appropriate logic, return true or false, whether things are moving or not. So in the update function here, first of all, if they are moving, I'm going to bail. So the update can't do anything until the balls have stopped moving. And I've got this pass parameter or variable too that's helping me keep track of that. So once everything stopped moving, I'm going to do a ray cast out from the camera to a point in the world. This is what I'm going to use to adjust the aim and velocity of my balls, of my cue ball that I'm firing out into the world. And so it's just catching the various positions here and making a line that we can see in the screen and making the magnitude proportional to the length of that line that I've created in the world and displaying the strength in the scene. I ran into an issue that when if your cue ball is near the edge of the world and you couldn't make a very long line. So I've got a boost that I can boost the strength to with another key. So now having set the line that's going to define the distance, I'm looking for either the F key or the G key. And the G key is only going to fire the ghosts. It's only going to fire the objects that are in the alternate world. And so they're going to go out and show me what will happen if I fire my actual cue ball ahead of time. And I do that with the F key, which fires both the real and the ghost. And when I'm done firing, I start this coroutine restore old positions. And the main purpose of that is in the case of the G key, where I've moved all the ghost balls, this is going to put them back where they belong after they've stopped moving. So the coroutine restore old positions, and here's a bug that I wrestled with for a couple of hours, was that if you did the test if moving right away, in this coroutine that it would find that the cue ball hadn't moved yet, and so it would return a true, and so it would go on and start setting the balls back to their original positions before they had even moved at all. And the solution for this was this wait 4 seconds. So this gives the balls enough time to get started on their travels before you start testing to see if they're moving or not. And literally this was a couple hours of trying to figure out what was wrong. So once they've stopped moving, I spin here in this little while loop until they stop moving, and then I get I set all of my ghosts back to the real positions, and you'll see there's a bit of slop in this whole system, even though they're allegedly doing exactly the same physics. Billiards is a very chaotic system, and so slight differences make big differences after time. And finally, a reset function that just reloads the scene. So here we go. I can aim my cue with this arrow, and with the X's and Z's, I can adjust the strength of this thing, and so I'll make it really strong, and I'll fire the ghosts. And so this shows me what would happen if I actually fired the whole thing. And so I do that now, and they fire. Notice the differences between the ghost positions and the real positions. That's that chaotic effect of billiards. And so this keeps track of how many shots I've taken. So if I do the ghost here, that doesn't count against my hits. If I adjust my aim a little bit here, and eventually I can get it to go in the hole. And the object, of course, is to clear this scene with the fewest number of hits. And so that's MultiPhysics. And I'll stop sharing there and entertain any questions. And on MultiPhysics. I'm sure there are other ways that one could do this, particularly with the rewind time tool, which would do the same thing. But this is another way of doing it. And I'm sure there are other things. That Ghost Racer that is one of the other tutorials there is a very fancy game with this complicated track that a little race car runs across. This is my dog who's getting antsy. But the object of that one is that after you've played a race, it makes a ghost scene that will replay the race. And so you get to race against yourself the second time around. You get to race against the recorded view of your race that you did the first time. And I haven't gotten it to work yet, but it's there, and there's a long tutorial on how to do it. So if you're interested, particularly if you're doing a racing game, Peter, yeah, Peter, you're doing a racing game that might be interesting for you, but not for this semester. That can be your your summertime challenge. So any questions? Yeah, the dog. No, the dog wants to pee. Is what the dog wants to do. Hi. You're a handful. You're a real handful. Any questions, comments, or suggestions? It's very funny. Yeah, she'll quiet down if I put my hand down where she can chew on it. She's chewing on my hand. All right, well, if there are no comments, questions, suggestions, I'm going to stop recording here.